Boys and girls, we started this on Friday, so I'm going to refresh your memory a little bit about the area model and using it to compare to the standard algorithm, okay? So it says draw an area model, then solve using the standard algorithm. Use arrows to match the partial products from the area model to the partial products of the algorithm. And so that's pretty much what we did Friday. It will all come back to you. Okay, so I'm going to use the number that they wrote on top of the standard algorithm. And does anyone remember where I put that? On top of the area model. And this is very important. Don't work ahead of me. So that means I'm going to break 21 apart into what two numbers? 20 plus 1. So here's where you write them. Now there's a very big mistake happening. So I'm going to be clear about this. Starting right now, we are going to solve this area model from the bottom up. And the reason is because I'm going to show you what kids are doing. Don't write this down, okay? They're doing 20 times 34. Well, it actually doesn't work here because 34 is the same on both. But when we get further down, let's just say we had a different number here. Let's say that was a 2. And so this was going to be 68. They accidentally do 20 times 68 instead of 20 times 34. Okay? So the best way to solve this problem is to start at the bottom. That way you won't accidentally multiply the wrong number. So I want you to do 20 times 34, anything times a multiple of 10? Okay, so we're doing 20 times 34. 2 times 4? 8. And 2 times 3. Now I will multiply 1 times 34. What do I get? 34. Now, I'm taking out a step. I'm taking out this step right here that we write the problem. So if I take that step out, you have to know what you're multiplying. Is it okay to take that step out? Do you know what two numbers you're multiplying? 20 times 34 and then 1 times 34. All right, so I'm going to leave this out and we're going to talk through it. So now we go over to the standard algorithm, okay? And if you want to use the turtle method, that's just fine. Jaden, can I get you to close the door, please? It's so noisy out there. So 34 times 1 is 34. Now, what do you think the number one mistake students make on standard algorithm multiplication?
To add 0.
They forget that you're multiplying times a multiple of 10. Or the turtle lays the egg, right? Okay, what do you think the second most common mistake is?
They write it the wrong place.
You're right. The numbers are not lined up correctly. So those are the two things I want you to concentrate on today, okay? So the place value of the 0 is right underneath the 4. Then you simply multiply 2 times 4 and 3 times 2. Now this is going to get faster, and tomorrow it's a lot harder. Now you add. Here's what I had one student do last block. See if you can figure out what mistake I'm making. I am. So sometimes, because it's so hard to keep everything straight, our brains get so jumbled up, we multiply and add and mix them all up. So just concentrate. What is 3 plus 8? And then regroup. Now someone said that problem's on Zern. Now this is only a review of Friday. Problem is, not everyone was focusing on Friday, so I need to go through the steps again, and I thank you for being patient, okay? I'll do the steps again on B. Let's take a look at it. So the first thing I check is, what number is on top of the standard algorithm? Okay, and here's what I want you to kind of try and remember. It's going to be the number with the most digits that you put on top. Not necessarily the largest, but the most digits. What am I breaking 21 apart into?
20 and 1.
Same thing, okay? What rule did I make today about this multiplication? On the area model, we're going to start from the bottom, okay? So write your 0. 2 times 4. 2, watch where my pen's pointing. 2 times 3.
6.
And 2 times 4.
8.
Then the next row is 434. Okay? You know what I forgot to do on the first one? It said draw arrows from the partial products in the area model to the partial products in the standard algorithm. I forgot to do that. Do they match? Okay, so I know I didn't make a mistake anywhere. Unless I made the same mistake twice, which isn't typical. Okay, so now let's do standard algorithm. So 4 times 1. Oh, this is just 434, isn't it? Okay, now I'm multiplying times 20, so I need a 0 right under the 4. And 4 times 2, 3 times 2, 4 times 2, add it up. Do my partial products match? And there you have it. That's kind of a review of Friday, okay? Actually, that's all you have to do on your exit ticket today. 2 area models and 2 standard algorithm, okay? So now let's practice just the standard algorithm, okay? So we'll do one together, and then I want you to do the next 2 on your own. So remember, I'm going to put the number with the most digits on top. So 431 times 12. How is this one different than the 2 we just did?
You're not using
I'm not multiplying by what? 1 to start with, am I? It's a 2. So be careful. Don't just write 431. You've got to do some multiplying. So 2 times 1.
2.
2 times 3.
6.
And 2 times 4.
8.
Don't forget your 0. And then 431, I guess, huh? Make sure you line up your digits. I almost don't have enough room, do I? So did you get the same answer? 5,172? Okay, write that on the line. You try the next 2 on your own. Now, if you make a mistake, we're going to talk about where you made it and why it might have happened. And make sure you write large enough that you can see where the numbers need to be lined up. I have a new niece. Her name is Penny. I don't hear that name very often. It's kind of an old-fashioned name. She's a sister to my nephew who was Bill Snyder. I know. She looks just like him too. Okay, so I'm going to work these out and you check yours with mine, okay? And thank you for being patient. I really appreciate it. Also, if I make a mistake, please let me know. It is a Monday.
Three and 4. Yeah, no, wait. That's like.
Oh, yeah.
Yeah.
Got it. I thought that was 12. Did I multiply?
Yeah.
What should I have done?
Added.
Added. that correct? Good job. Finding my mistake. What? Oh, shoot. You're on the ball today, I tell you.
Oh, I did 6.
Yeah, you want to try not to make the same mistake I just made.
No, wait. Is the 6 supposed to be a 9?
I got it. I was multiplying on purpose to see if you could catch my mistake, okay? Did you catch it? I know. Good job. Okay, that's the main problem we had today, actually. Most people remembered their 0, okay? All right, let's take a look. This is a fun problem. It's going to kind of make your brains have to work a little bit, which is a good thing.
Where's our challenge problem?
Well, this might be it, although I helped you. I think maybe we'll use 4 as the challenge problem. No, oh gosh, what should I do? Eeny, meeny, miny, moe.
The first one you do is going to be...
It's harder. Should you try this one as your challenge problem?
Yes.
Okay, so let me read it and then I'll push pause.
Wait, whichever one's harder.
This one's harder.
Alright, let's go.
The bottom one is just what we did today. Okay? It says Betty saves $161 a month. Now don't start writing before you finish listening. Okay? She saves $141 less each month than Jack. How much will Jack save in 2 years? So this is going from months to years. I wouldn't worry about months to years until you get the answer. How much does Jack save a month? You've got to figure that out first. Okay? Wait, I'm going to push pause. Okay, let's take a look at the next problem. Farmer Brown feeds 12.1 kilograms of alfalfa to each of his 2 horses daily. How many kilograms of alfalfa will all his horses have eaten after 21 days?
For 3 weeks.
3 weeks. So draw an area model to solve. Now here's what I want you to think about. You got to figure out how much he needs per day. And then you're going to take it times 21 days. So how much does he need per day? Somebody raise your hand and tell me. Well, first of all, how many horses does he have? 2. And Katie, how much is he using for 1 horse?
12.1.
12.1. Let Katie answer.
Katie's just starting off.
So Katie, oh, thanks for being rude on my video even. So Katie, this is 1 horse for 1 day. So how much would 2 horses for 1 day be? Can't I just add it up? That's right, 24.2. Or I could have multiplied it times 2. But it's pretty easy to add in your head, isn't it? Because you know 12 plus 12 is 24. So that goes on top. Now here's what I want you to do. Take out the decimal. Get it out of there. It's going to confuse you. And what place value are we talking about? Tenths. Just write the word tenths instead. And then if we take this times 21 days, how will I break 21 apart?
20 plus 1.
Right, we've done that several times today, haven't we? Okay, now here's what I want you to do. Start at the bottom. So 20 times 242. That's what I have to figure out first. 20 times 242. I know it ends in a 0. I can put that down. Here's the math. 2 times 2.
4.
2 times 4.
8.
And 2 times 2. Okay? Now, 242 times 1. So when we get our answer, if we were going to add it up here, the answer would be in what place value? Tenths. So we can't forget about putting that decimal back in. Okay, standard algorithm. What goes on top of it? 242 tenths, right? And you can't just write 242 or people will think it's ones. You got to write the word tenths there. And I'm going to take that times what number? 21. Look how I wrote it. Okay, write that down. So then if you want to use the turtle method, go right ahead. Line up your digits. Don't forget about your 0. And then you've got to have the word tenths on your answer, or on your final product. Do my partial products match?
Yes.
They do. You know, that's a good way to catch it if you forget the 0, isn't it? Yeah. Okay, so showing this now, with the decimal back in there, Brian, where would you place the decimal?
Between the 5 and the 0.
Well, you got to think about tenths place. You're right, it's one place value. You just got it on the wrong end.
Between the 8 and 2.
You're right. So per day times 21. So in 21 days, how many kilograms of alfalfa? 508.2 kilograms. Now, we don't know how much a bale of alfalfa weighs as far as kilograms. But does anyone ever use bales of alfalfa? Okay, how many pounds is it?
Like 1,000.
1,000. So you're getting really big bales, aren't you? Okay, all right. Greg was telling us about these little bitty bales that he feeds his bucket calf. He'll eat the calf, I don't know how many they have, but he goes through about one a day, and they're $14 a day. So it's quite expensive to buy alfalfa for your livestock, isn't it? That stuff isn't cheap. Okay, let's talk about the exit ticket. It's very simple, except for one thing they throw in there. They're trying to trick you. So look at number 1 and see if you can figure out what the trick is. It says draw an area model, then solve using the standard algorithm. Before we do anything, I want you to figure out what the trick is on number 1.
They switched the 21.
They did. Okay, I would have put the 21 on the bottom, wouldn't you?
Yeah.
But we're going to go with this. We can handle this, can't we?
Still get the same answer.
Still get the same answer because it's a commutative property. So instead of breaking apart 21, what am I breaking apart? 23. So that's going to get a little bit different result. I'm not going to give you any more. At the bottom, it's pretty typical. Take a look at the bottom. What goes on top of that one? That area model, what goes on top? 143, thank you for answering. And 12 is broken apart into 10 and 2. Now don't make this harder than it is. Boys and girls, what was my advice?
Start at the bottom.
Start at the bottom. So do 20 times 21 first. Okay, trust me on that. Now what